Hi, I'm Erwin Parra. I'm application specialist here at Fluke Calibration, and I'm gonna show you how to use the 5560A multi-product calibrator and how to calibrate DMMs and clamps. Let's calibrate a DMM, in this case an 87.5 in DCV. So first, I need to check the connections. They're ready. Green lights, voltage connection. And I get 1 volt. 1 volt seems to be good. Next point, let's pretend that I have to do 2V. And I need to follow all the manual points. So now I'm calibrating 40 volts. I need to check that 40 volts there, get my numbers. If you notice, this light turns on, means that is potential dangerous. Be careful, use the protection. 100 volts, DC. I get my indication that it's dangerous. 100 volts, we're good. And then I'm be done with DCV. Now I'm gonna jump to ACV. In this case, I don't need to change the cables. So 1 volt, 60 hertz, enter. And then I need to change my knob to ACV. I got 1. You need to wait to stabilize. And then same process that I did in DCV, jump to the calibration point that the manufacturer indicates. Let's change the frequency. Yeah, 1 volt. Let's do 120 and 60 hertz. Careful. 120. Looks good. Now when I'm done with ACV, I need to jump to resistance. So same post here, same post here. I need to change the knob. Now I'm doing 12 ohms, getting 12. This is resistance in this case, 2 wire in this case. 100 ohms. And I'll be continuing doing all the calibration steps that I need to do according to the manual. And then I'm done with resistance. I need to stop and change the connections because I'm gonna do current. So 1 amp, don't do it now, wait, you need to change the connections here. Now indicated in blue, visual management, and I need to change the leads here, my DMM. In this case, I'm gonna use yeah, he knows. So I'm gonna do DC current. Yep. We're good. So now I'm sending 1 amp, reading 1 amp and 1. And the same. 2 amps. 2. Spot on. This meter goes up to 10 amps. Be careful because this unit goes to 30 amps. Don't break it. If you exceed the current, you're gonna be breaking the fuse. For 5 amps, I need to change the post here in my calibrator. Then I sent 5 amps and I'm getting 4.999, which is common and good. That'll be doing more points, up to 10 amps, which is the last one. Yeah, 10.00, I'm good. Next, I'll be jumping to AC current. 1 amp, 60 hertz. I need to check the post. Yeah. Then change to AC. Then sending 1 amp, 60 hertz. 0.999. 1. I waited. Then 5 amps, 60 hertz. I need to change the post again. my calibrator will tell me which post I need to use, so pay attention to the lights. 5 amps, good? Yes. Perfect, 5. Then last point, 10 amps in this case. And I'm done. So the purpose of calibrating a DMM is basically comparing a known source with my unit under test to check if I have an error and how much is the error and how that my unit is performing on the field. So that's basically comparing a known value with an unknown value, and that's what calibration is. Now I'm going to show you how to calibrate clamps in AC current. In this case, I'm going to use 1 amp for starting. So 1 amp, I'm using a 50 turn coil. So everything that goes out from here get times 50. So 1 amp, 60 hertz, looks good. Operate. Then I'm reading 50.4, which is fine. Stopping. And I'm going to use this next point, which is 2 amps. 60 hertz, so I'm not going to change that. Same post. Looks good. Operate. And I'm reading 101 amp, 0.0. All is good. Stop. The next point is 5 amps. In this case, I need to stop because calibrator is changing the post. So I need to be paying attention to that. No changes there. All is good. So 5 amps, I'm reading 252.8. And standby. Next point, 10 amps. Oh. And I'm reading 505.4 amps with 60 hertz. That will be the calibration of the AC current of the clamp. If you want to calibrate the DC voltage, you need to use lower post, and it will be the same as a DMM. Now I'm going to calibrate a Tektronix oscilloscope with using the 5560A multi-product calibrator from Fluke. In this case, I'm seeing my scope options. I'm going to use level sign, 200 millivolts, 50 kilohertz, hit operate, and I'm seeing the signal. This is going to be visual. I need to check the numbers and seeing if I'm getting the right measurements. So I'm seeing 208 millivolts, which is good. I'm reading the numbers here. Everything looks good. I need to follow that manufacturer's manual to do all the points. And that will be the calibration of the reticule. When I'm done with the level sign, I'll be jumping to bandwidth testing, which is interesting to see. So I'm going to show you how it is the bandwidth testing. This oscilloscope has 500 megahertz bandwidth. This unit has 2 gigs, so it's 4 times better. I'm going to jump to 500 megs. Better view. Now I can see 200 millivolts, 500 megs. And I'm seeing an attenuation, which is normal. And I'll be in the bandwidth when I've reached the 30% of loss, which is the 70% of the signal, which in this case will be 70. So I'll be increasing the frequency to see how my signal drops, which is what I'm expecting to see. And then around 526, I'm seeing 70% of the signal. So I reach my bandwidth. And that will be the bandwidth verification of my scope being calibrated with my 5560A multi-product calibrator. And if you follow all the manufacturer steps, you'll be doing this calibration. You need to use a special cable. Don't use regular cables. You need a good BNC connection cable. And be sure that you're doing what is expected with the calibration manual. Well, that's it. That was calibrating DMM, clamps, and oscilloscopes. If you have any questions, go to fluke.com and we will be happy to help.